Good morning, everyone. I'm going for the shortest keynote title ever. So compressed time to play defense down to D. Before I start, with a quick show of hands, how many people here work as pen testers or red teamers? That's an interesting number. The rest of you guys, defenders? Okay, that's interesting. Super quickly, I want to say thanks. Thanks for coming out for the talk. I know it's early. I know the second day of the conference, you normally suffer because of the first day of the conference. And most keynotes that I've actually seen kind of suck. So I want to thank you guys for showing some faith. I also want to apologize up front. I saw the tweets on Costin's keynote yesterday, and it was great. And mine's is not going to have any 0 day in it. In fact, nothing new. In fact, lots of the stuff is actually decidedly old. And it's not because I'm lazy. I might be lazy, but that's not why it's old stuff. For the most part, it's because the stuff I want to talk about today is a collection of thoughts that I've had for a long time. And it's almost a progression of some of those thoughts. For the most part, I think you're doing okay if a keynote gives you a bunch of resources to check out and a bunch of new thoughts in as I go. Sorry. Okay, so a few years ago, in around 2011, I did a talk called Penetration Testing Considered Harmful. Okay, and what was interesting about this is it was on the back of about 11 years heading up a company that did pen testing for a living. Okay, so for the most part, I was the technical director of a company called SensePost. And what we did for a whole bunch of time was break into networks, break into applications, and write books and do talks on how to break into networks and break into applications. But one of the things that I started seeing was that pen testing wasn't completely helping customers. Okay, I was talking to someone in the car, one of the other speakers, and if you're a pen tester, one of the things that you'll know is most of the time your days start to kind of blend together. Even if you end up doing really cool on an attack, you start to hit the point where you know you can write the customer report before actually going to the customer. And a few years more into it, you start to figure out that none of those customers are getting significantly better. Okay, and the point I was making at the time was lots of companies were paying lots of money for pen tests, and for the most part it wasn't appreciably moving the ball forward. And at the time what I was saying is that in security we were starting to end up building a house of cards. Okay, because people were paying lots of money, boards were taking an active interest, and for the most part boards just had no idea how insecure they were. Like, an old trope that security has been doling out for a long time is management don't buy in. And around 2011, I felt that stopped being true, right? Because instead of being one or two guys attending DEF CON in your spare time, everyone was doing conferences like this, okay? So people were paying hundreds, thousands of dollars. There was lots of money in the industry. So boards did buy in. They just didn't know that their buying in didn't help, because they were paying us as security guys, and for the most part, most security guys were doing stuff, but actually just hoping that when the attack came, it didn't come on our watch. Okay, because for the most part, that's what we were doing. And you still find a lot of this if you play defense, because Equifax happens, and everyone looks at it, and everyone can point out how silly it was. And if we're honest with ourselves, we all know that we just one bad day from our Equifax moment, okay? Because that's just how it is. And for the most part, everyone's just keeping up this deception. And at the time, I gave a simple razor or a simple test. And my test was this. If you work for an organization, or if you've just done work for an organization, how many 0 days would it take for me to get to your company's crown jewels? And at the time I asked a whole bunch of my pen tester friends, And the general answer, I'd be keen to hear if you guys say any different, was either 0 or 1. Okay, so 1 0 day ends up being the worst day of that customer's life. And if that's where we were after years and years of pen testing or years and years of security, then clearly we were doing something wrong. The end of that talk, so the whole point of that talk was not just to alienate me from my friends in the pen testing business, but for the most part, what I was saying was that the security community had ended up with a local maximum. Okay, so for the comp science nerds in the crowd, you'll know that when you're doing a hill climbing problem, sometimes you end up on the wrong hill. You hit a peak, but you're on a local maximum. And the way to solve this problem is to do a reset, find another hill, and start again. And largely what I was saying back then was with pen testing, we were on one of those points. We'd gone as far as we could go with it. We weren't solving a big enough chunk of the problem, but we were just doing more and more of it. And instead, what we needed to do was step back and look for fresh approaches. And of course, since 2011, things have just gotten significantly worse. And one of those reasons is just complexity, which just keeps marching on. One of the canonical examples that I like to give on this is the Linux kernel, which started off all happy and hippie with 10,000 lines of code, and today is something like 20 million lines of code. In fact, if you take a look at your web browser today, depending on what you're using, your web browser has something like 20 million lines of code in it. Okay, we're rapidly approaching, we're way past the point where the stuff can be formally verified reasonably or just manually tested. And the stuff keeps getting worse and worse. I've given some of these examples before, so I won't spend a lot of time on it. For those of you who don't know, there was a tiny Mac company that was trying to do AirPlay stuff and found artifacts on their VGA adapter, on their graphics adapter. So they took a hacksaw to it and found out that in a typical Apple video adapter like that, there's actually a system on a chip with 2 gigs of RAM. So when you look at this VGA adapter, it's not just a VGA adapter, it's a computer. Okay, and down there's a guy called Jerome from SpritesMod who ran Linux on the controller of a hard drive. Okay, so he didn't install Linux in his hard drive, he ran it on his hard drive. And the last example that I give there was Bunny and Zobs a few years ago did a talk at CCC where they found that those tiny 20-cent SD cards also have microprocessors that could also be subverted. So they wrote tiny rootkits for those SD cards. And the thing for you to ponder here is we hadn't figured out how to secure things when we thought we were aiming at a single processor that we call the computer. But now even your computer is a series of processors. If you've got a MacBook, you'll know that your little touch bar thing effectively is WatchOS running on your machine, so it's a whole new machine. But all over your machine, there's just more and more processors waiting to be abused. And while complexity rockets, we've got a problem in that we can't find enough good people to keep up with this. A few years back, the guys from Leviathan Security did an in-depth look on the jobs problem, and they ended up saying that if every employee at GM, Costco, Home Depot, Delta, Procter & Gamble became security experts tomorrow, there still wouldn't be enough people to fill the need that we've got. And all of this could very easily lead to something that's pretty rife in the industry, which is security nihilism. Okay, the thought that it's all broken anyway, I'm going to have some fun and go drinking. Okay, but part of what I want to say today is that there's good reason not to give in to nihilism, that there's good signs that there's a better approach out there. And for a long time, we didn't really have this. So when I gave the pen testing considered harmful talk in 2011, for example, I didn't have a solution, and I didn't even really have a ray of light. I was just saying, we're in trouble because what we're doing is broken, and we need to find alternatives. And fortunately now, we're starting to see some rays of light. One of them, strangely disguised, was in the Apple versus US government in the San Bernardino case. Okay, and the reason why I say this was a ray of light, for those of you who don't remember, there was a terrorist attack. He had an iPhone. iPhone was locked, and the US government wanted access to it, and they tried to compel Apple to give them access to that phone. Now, what's interesting about that is you're starting to see for the first time changes to what we used to consider the immutable laws of security. Okay, so for those who've been around for a long time, you'll remember Microsoft used to have this document called the 10 Immutable Laws of Security. And law number 3, which was always taken as a given, which was if a bad guy has unlimited physical access to your computer, it's not your computer anymore, now starts to show signs of not being so true anymore. Okay, because if you've got an iPhone, a modern iPhone, not the 5C that was used in that case, that's running secure enclave, you're starting to get to the point where you've actually got secure hardware at commodity prices. If you buy a modern Chromebook, okay, you're starting to get to the point, if you ignore Infineon and silly mistakes like that on the way, you're starting to get to the point where you've got hardware that's resistant to attackers. Okay, and you're also starting to see, for the most part, companies that are starting to truly get security. Okay, if you're going to talk to Google or talk to Project Zero, those people are not doing security in their spare time anymore. Last year, Ivan Kristich from Apple gave a talk on how they're making iCloud happen. And they've got incredibly ambitious goals, right? They're at the point where they say you could lose access to all of your devices and still get your data back, but nobody at Apple has any advantage getting to this data. And the talk is interesting and worth watching because they do a whole bunch of coolness with HSMs, and they've got it down to both technology and processes. If you get the chance, you should watch that talk. But it's not silly companies making silly mistakes anymore. There's a lot of really good security analysis and design going into this. And you see this coming through in lots of different places. Okay, if you use the price of vulnerabilities as an oracle, you can start to see that some companies are genuinely getting something better. For all of that sunshine and hope, where we are truly sucking is still enterprise security. Okay, most enterprises today, like I say, are waiting for their Equifax moment. Most guys just don't have a chance. If you look at nearly all the industry reports, they talk about dwell time, meaning attackers live on your network for between 200 and 300 days before people realize that they're on their network. And in lots of cases, even that number is slightly wrong, because if you take lots of the large breaches that happened recently, the ones that are made public, part of the reason people find out about it is because the data self-identifies. So Target get breached for months. The reason they find out about it is because someone uses those credit cards somewhere, not because Target suddenly figured out that people were on their network. Okay, and if you deal in a business where your data doesn't self-identify, if the only time you find out you've been owned is because a competing country builds a fighter jet that looks a lot like your fighter jet, then chances are that dwell time is a serious problem for you. A few years ago, Alex Stamos gave a talk at AppSec USA, and he actually said, if you ignore how bad that slide is, he said, if you take the Fortune 500, there's the Secure 100, which are just 100 of the guys, but just a few of them, who actually know how to play the security game. And he referred to the rest of them as the toasted 400. Okay, saying these guys are horribly broken and don't know that they're horribly broken. I've spoken to lots of people in the field, and so far I've not heard anyone say, hell no, that's incorrect. Those other guys definitely know how to play the game. And what we're talking about there are billion-dollar companies, okay? And if 400 of the 500 billion-dollar companies are considered the toasted 400, then you need to take an honest look at your organization and try to figure out where you sit on that spectrum. And so again, all of this pretty easily leads to some form of nihilism, which again is what I said we wouldn't do. So what we've got to do is ask ourselves two questions. A, why are we failing so horribly? And B, if there's anyone who's not failing, or if there's anyone who's managing to get enterprise security right. And if you start questioning why we currently can't secure our companies, you figure out that there's actually lots of reasons for it. Certainly more reasons than some monkey is going to give you by standing in front of you at 9 a.m. in the morning. So there are lots of reasons, and the fact that there are lots of reasons becomes part of the problem. Okay, because it turns out that we're doing lots and lots of things nowadays that probably should have died out with the dinosaurs. Okay, if you're part of any enterprise security program, you'll find that you've been hiring more and more people to do more and more tasks that actually don't significantly move the ball forward at all. Okay, it's easy to pick on things like password change policies and forcing people to include hieroglyphics in their passwords. But if you really take a look at what lots of enterprise security programs do today, you'll find lots of other stuff that we've considered truths in the past that possibly don't hold anymore. I've spoken to lots of customers for whom I don't think security spending their time on patching is the right solution. I think they've got other parts of the problem that significantly affect them more than making sure all of their Windows servers are up to date. It's a whole talk on its own. If there's one thing that I'd like you to take away from this talk, though, it's that for the most part, against a deliberate, determined attacker, most generic solutions fail. Okay, and there's lots of reasons for this. For a while in security, people were saying things like, why can't we just use engineering? Because look, we've learned engineering to build bridges, and they give you the example of the Tacoma Narrows. And they tell you how people learned how to build bridges and now they don't. And of course, the reason why this isn't a one-to-one match is because in security you deal with sentient opponents. Okay, when you build a bridge to beat Mother Nature doesn't change her plans to beat you back. Okay, but in security with sentient opponents, this is what happens. But this is also why most generic solutions fail horribly. Okay, because if you're running AV on your network or certain AV on your network and an attacker wants you badly enough, he'll figure out that you're running that AV and figure out how to bypass it. AV is probably a bad example because it's almost harder to not bypass it. And Dino Daizovi, who's always super quotable, picks on AV in particular when he says, well, yes, this is the perfect security anti-pattern, right? Where you've got a vulnerable target, and so what you do to try to protect it is add higher privileged, more vulnerable code on top of that. And it's the perfect segue into picking on antivirus. Taviso for a while at Google has been hammering on them, pointing out that it's 2017 and no AV uses sandboxing yet. So you've got code that runs at the lowest level, whose job it is to parse everything that comes in, and none of it is sandboxed. How's that going to end well? And it's not just Taviso, right? Joxian Corrette for a while took aim at Komodo, and at some point he tweeted something like, hey Komodo, it took me longer to install your software than to find the first bugs in your software. Security software in general doesn't do too great. Veracode did a report a few years back, and they found security software came second only to CMSs in terms of poor code quality. Stamos, again, in that same talk, spoke about how useless box solutions are against attackers. And at the time, he said, look, we used to be big FireEye customers. We're throwing all our FireEye boxes out. And it wasn't a hit at FireEye. What he was saying was, if they expect nation-state opponents, if they were buying FireEye boxes, it was pretty obvious that their opponents were buying FireEye boxes and working on them. And so if we say that these generic solutions fare so horribly, then my submission for the most part is that good defense becomes a series of internal hacks. Okay, and this causes a little bit of cognitive dissonance, because for a long time we've been told not to go for quick, dirty internal hacks on your network. We've kind of been pushed into the thinking that said that if you have solutions on your network, they need to have enterprise SLAs and they need to come in a shiny box. But more and more what you're starting to see is that the world changes too fast. And by the time vendors have figured out how to package a solution, box a solution, put it in a pizza box and sell it to you, it's not really clear that those solutions are useful anymore. And I want to give you a strange proof of this argument in the form of the NSA. Okay? And one of the things that you see from the Snowden leaks is that the NSA as attackers were truly unashamed and unafraid to embrace the hackiness of stuff. Okay, so often you'd find an exploit or some sort of attack tooling or methodology from them, and the moment it hits Twitter, you'll have a bunch of people pointing out why that attack is stupid or why that attack is not optimized. And for the most part, what you'll notice is it's not optimized, but it works. One of the most interesting revelations from there was one called Fashion Cleft. I'm not sure how many of you see it or saw it, but Fashion Cleft had like a 26-page document on a new protocol. And essentially, their protocol was for tunneling packets inside of packets. And what they were doing was trying to make sure that we never get good attribution. So normally, when there's an attack somewhere, the easy way to get attribution is to look at where the data is going. So you've been attacked. The box that attacked you was from China. So you say China attacked you. And after a while, people figured out that since the 90s or 80s, attackers were using jump boxes. So first I'd break into the University of China, then use that box to attack someone. And so what would happen is if you had good visibility on the network, essentially what you'd do is you'd watch who talks to that compromised box and you'd figure out who the attacker was. And so what the NSA were doing with Fashion Cleft, which was super cool, was they'd own the box on your network, they'd then bundle your traffic inside of other traffic and send it out on the internet to host B. But with no interest at all in host B, they just make sure that it routed past an NSA listening post, which would then sniff the traffic off the wire, look for a marker in the traffic that said this was Fashion Cleft traffic, then decrypt it and then pass it on to its ROC. Now, what should be interesting if you look at that solution is that it sets them up for a problem. Okay, if you figured out what the marker was that made Fashion Cleft think it was a Fashion Cleft packet, you could generate lots of traffic, and all of these NSA listening centers would then take your packets thinking it was Fashion Cleft traffic, try to decrypt it, and try to pass it on. Okay, the fundamental problem here is by doing a very little bit of work, you could make them do a lot of work. And anyone will tell you that this is bad design. But what they embraced there was that okay solutions that work now are better than perfect solutions that will work at some point in the future. And what I'm saying is we need to do more of this inside our organizations. Some quick, stupid examples. For those of you who are pen testers here, most pen tests still end when you've ended up with domain admin on your customer network, and people still celebrate. For those of you who are pen testers, how many times, with a quick show of hands, how many times have you ended up with domain admin on a customer network? Show of hands, have you ever? Yep. Okay, how many times has the customer noticed you were domain admin on their network? Okay, now if you think about it, that's a ridiculously stupid problem to have. Okay, because with 3 lines of PowerShell, you can get a notification every time a new user is added to the domain admins group. Okay, and so with 1 line of PowerShell, you'd find out who's added as a domain admin at any given time. And I've done pen tests for 11 years, and we've never had a customer say, oh, we just noticed you were added to domain admin. Most time, customers find out about it when you hand in your report. Okay, and if you're a defender and you don't know when new domain admins are added to your group, this is something you should be considering. We put out a tool, and it's free, so I'll happily talk about it, called Canary Tokens. And Canary Tokens are so stupid to the point of being remedial. Like, it's literally an evening's worth of bad Python. And the way Canary Tokens work are super simple. You go to it, there's a bunch of options that you can choose for what type of token you want. You put in, so in the example here, I'm choosing a web bug, which again is not rocket science. I choose an email address to say, mail me on this email when you get a hit, and I put a reminder. The server comes back and gives me what we call a canary token, which looks something like that. Okay, and if you feel like, you can change that URL slightly, so it says secret.pdf. And the logic here is simple. Take this token, put it in your email as email number 1, or save it in your Dropbox, or post it on your company Slack. And the logic is that at some point when you compromised, some attacker is going to surf to it, trip this token, and you'll get an email at that email address, which will tell you, hey, listen, this guy from this IP address at this time just visited this. And of course, because we've got him to visit a page that we control, we can do a little more. We can start geolocating where the IP is from. We can tell you what stuff is running in his browser, what plugins he has. If his browser has a WebRTC leak, like Chrome does, we can tell you what his true IP address is. And with a primitive like that, you can actually do a bunch of different tokens. Like, we can give you a Word doc, and when the Word doc's opened, it'll beacon out, or a PDF file that beacons out. We can give you fake AWS keys. So the moment someone uses the key, you get a notification. What's interesting about Canary Tokens is, like I said at the start, it's dirty, simple hackery. Okay, literally, it's nothing that people couldn't piece together in Perl in half a day. Okay, but it's dirty, simple hacks that absolutely work. Okay, with that Canary token server, which is sitting out on the internet, we've seen law enforcement unmask people on dark markets. We've seen the guys from Amnesty International unmask the Iranian government. So literally what happened was the government was hacking dissidents. What the guys did is they generated some tokens, left it on the dissidents' machines. The attackers grabbed them through a VPN, but then opened those documents inside of Tehran. Okay, and you see cases like this where a customer says, listen, we took these documents, we left them on our web server. After we shut our web server down, we found those documents being accessed or being opened up in Russia. And again, my point is the defensive tooling here is ridiculously simple. Okay, it just needed someone to go and do it. And it's something that you'd almost consider too much of a hack. Because what if you put the file on your file server and your sysadmin opens it up? And my answer to that is, then your sysadmin opened it up. And on Tuesday, you've got a false positive. You ignore it and you move on. I did a talk at T2 last year, which was largely based on the fact that we've been learning the wrong lessons from offense all these years. Like we've been doing offense and saying you must learn the lessons from offense. But one of the lessons that offense deeply internalizes is to handle errors better than we do in defense. because attackers kind of expect things to not work and they move on. And in defense, if a solution is not perfect, then we throw it out. Okay, and largely that's the type of thinking we need to get rid of. Zane Lackey, anytime you get a chance to watch a Zane Lackey talk, you should. Zane Lackey did a talk called Offense-Oriented Defense, and he talks about how often ipconfig, uname, and whoami are ever run by people who are non-malicious. Okay, it's either run by pen testers or sysadmins, and he says, look, on your network, instrument just these. Wrap these binaries in something that'll make a call out to you, because chances are, if someone's running whoami on your network or on one of your boxes, it's either a pen tester or you've been owned. Okay, and again, it's dirt simple and will probably throw some false positives, but I've seen it have success in a whole bunch of cases. Again, it's not going to take you a lot of effort to do. It's quick, it's cheap, it's dirty, but it works. So the one thing that stops most organizations from doing this sort of stuff is it's simple. Like if you watch any ISA security talk, and about 90% of the RSA talks, at some point they'll tell you that security is all about people, process, and technology. And I think that's wrong. I think it's about people. Okay, and the main reason I say this is I think if you've got the right people, they'll figure out the process and they'll figure out the technology. But if you don't have the people, all the technology and process in the world is not going to help you. And yeah, I'm saying we need to do something about our people problem here. And so I'm going to look at this in 3 parts. Something for security management, defenders, and guys playing offense here. Parisa Tabriz in 2015 said it perfectly when she said, look, if you're going to RSA, just save the money, spend it on some smart people, and then listen to those smart people instead. And you see this problem quite often, right? You see that many organizations will spend lots and lots of money on security infrastructure, but absolutely wouldn't consider paying the same amount of money on people. Okay, where quality people will absolutely do better than those shiny boxes will. And if you're a manager, if you're a CISO and you're in the crowd, and you recognize this about your organization, then when you go back today or tomorrow, you should realize that fixing that problem should probably be your #1 problem. Okay, fixing that in your org will go further than just about any password change policy that you're going to implement. And so a logical question becomes, well, if you have these people who can implement these hacky solutions, how many of these people do you need? And it's an interesting question. Andrew Case, very smart, author of the volatility framework, he recently made a comment on Twitter where he said that, hey, Slack don't have that big a security team. So he doesn't trust them because they don't have as many people as Microsoft. And Ryan Huber, who works for Slack, responded perfectly when he said that, yeah, headcount is absolutely the metric you should be going for when you look at quality of a security team. And Ryan should know, right? Because like if you haven't seen it, Ryan does a talk on distributed security alerting. And Slack are one of those companies that are super, super interesting because they've taken a different approach to their enterprise security. And because every good talk should reference 300 at some point, the scene that I want to talk about is this one, right? When Leonidas meets the Athenians, and the Athenian says, we've brought more soldiers than you. And Leonidas points out that they've brought more people, but Spartans had more soldiers. Okay, and I think that there's an interesting lesson for us with this for how we staff our security teams also. You can have hundreds of people running around patching servers, doing checklists, and you have a constantly growing security team. And you know, as your team grows, communication overhead grows and management overhead grows. or you have a handful of people, but your handful of people are Ryan Hubers. Okay, I'm not saying it solves the people problem, because it's still hard to find a Ryan Huber, but we're finding it hard to find the hundreds of people right now. If you're talking about defense, so I spoke about Slack, a question has to be, are there other people getting this right now? Are there other people getting enterprise security right? And if you take a look, you'll see some of these new companies, Facebook, Etsy, Square, Airbnb, lots of them are starting to do this better. And if you take a close look at them, you'll see an interesting thing. So for those of you who haven't seen OS Query came out of Facebook, came out of Airbnb. It's an open source tool to do fleet management. Airbnb released a way to manage it in the cloud. A few years ago, from Facebook did a talk on the work they did to take two-factor authentication into Facebook. And if you haven't seen this talk, you should go check it out. It's super, super interesting. Because 4 points out that with 6,000 employees, even the overhead of taking out a key to look at it or doing a two-factor push ends up being too much friction for his users. And so they ended up with a solution that was awesome. It ends up using YubiKeys, Duo, and custom patches to SSH. But the end solution that they ended up with allows people to two-factor authenticate quicker than not using two-factor authentication. So now staff at Facebook use two-factor authentication not because it's more secure, but because it makes their life easier. The side benefit is that it's also more secure. Okay, I'll go through this quickly because I'm running out of time. Diogo Monica and Nathan Macaulay, this talk recently, Wired did a piece on it, and so lots of people were talking about it, but they did a talk on using crypto anchors in your environment. So crypto anchors essentially mean that if your web server gets compromised, it doesn't lead to, like I said, the worst day of your life, because an attacker can't then take all of your data off your network and use it. Essentially, they've got to talk to an oracle on your network, which then does the decryption or does the password management. What's interesting for me about what these guys did at Square is that it's a changing role of InfoSec. So these are InfoSec engineers, but they're writing code that's deliberately in line with every Square transaction that happens. Okay, and it's kind of different to how we were doing security all this time. What you should notice is in none of those examples are security the guys with checklists telling you what you can and can't do inside of the organization. For the most part, what you're seeing is a move to security actually doing development. Every good presentation should also have that bomber scene. So this isn't a new concept, right? When Alex talked about the Toasted 400, when asked to specify what differentiates the 100 from the 400, his answer was secure software engineering, engineering-focused incident response, and the ability to create, not buy solutions. Okay, and this should be fairly obvious, okay, because in the words of Mark Andreessen, software is eating the world. Okay, it would make sense that software eats security also. And it's interesting also because software is a force multiplier. Okay, software is the reason why 11-man Instagram can make $1 bazillion by selling their company, because they managed to leverage software. Again, one of the Facebook talks, a guy called Subodh Iyengar, gave a talk on how they manage code security for mobile development. With hundreds of developers, hundreds of thousands of commits, Facebook manages it with 3 security engineers. Okay, and part of the reason they get this right is because those guys are not just sitting there telling people you did this wrong. They build secure libraries, they build secure infrastructure to make the rest of the guys' jobs easier. So what we really need are security people that enable business. Rich Smith, when he was at Etsy, did a really good talk about building a security culture at an organization. And he points out, your team's success should be measured by what they enable, not what they block. And that any security team that introduces blocking to the org will be bypassed and will be ignored. He says an interesting thing at the end of it, where he says that if your security engineers don't like hard problems and novel solutions, you've got the wrong security engineers. Okay, that's what they should be doing. They should be finding ways to enable stuff, not finding ways to tell people no. So really quickly, I'm going to hit some common Defender hang-ups. One of them is this. When you run on an obstacle course, you expect obstacles, okay? Most defenders would tell you how they could absolutely defend their network if not for those pesky users. The reason we get paid as defenders is to figure out how to defend it with those pesky users. Okay, those users are not incidental to the problem. They actually what forms the problem and what we need to engineer around. The second thing that always comes up is, well, that might work for Airbnb, but it wouldn't work for my organization, or it might work for Slack, but not for us. And at this point, fortunately, the alternative is so bad. Like if you realistically say to yourself, sure, Equifax could happen to us tomorrow, then actually you're in about rock bottom, right? You might as well try something different. Because what you were doing wasn't having any positive results anyway. And something that's super interesting to me here is, like, if you watch a typical security conference today, you'll find dozens and dozens of talks on people who are now, like, it's a whole niche section called social engineering and human hacking, and people focused on how you can fool people. But at the same time, we talk about how we can't infuse security culture into organizations. Okay, that's just a long-term social engineering gig. If you can social engineer victims but can't social engineer management into doing what you need to be doing, then you need to ask yourself why. For those of you who are playing offense, really quickly, if you're red teaming, I want to invite you to come over to the blue side. For the most part, because I think there's interesting fun to be had here. Like when you're pen testing or red teaming, you start off with the question that says, can you own this network? And for the most part, over the last few years, you should have figured out that that's kind of like taking candy from a baby. And most of us get into red teaming for the intellectual curiosity. You really want to know if you can solve the problem. But I want you to pause for a moment, and if you're honest with yourself, you should figure out that there's not that much intellectual curiosity in that anymore. Yes, you can own the network. You totally can. The bigger question, or the one that's unanswered, is, can you defend it? Can you figure out a way to secure the CEO or CFO without making them a security power user? Can we run untrusted libraries in our web server code and still find a way to sleep easy at night? Can we find a way to let our users click on any email attachment they get and still not get owned? There's a whole bunch of really beautiful, really interesting problems waiting to be solved. And these days, the more interesting problems, at least when I look at it, seem to be in defense, not offense. I'll end super quickly. So Tim O'Reilly has ended a few of his talks quoting this poem from Rilke, which essentially says, for the most part, what we choose to fight is so tiny. And you see this a lot for the guys playing in security offense. And we have these victories, and for the most part, we end up scribbling in the margins of other people's work. And for the most part, what I want to say to red teamers is, there's lots of good solutions waiting to be built. There's lots of hackiness waiting to be built, and the results will be longer lasting. So for the most part, our old way clearly wasn't working. Enterprise security should be seen as an engineering problem. Organizations that are treating it like an engineering problem are figuring solutions that actually work. You need to hire good people, and then good stuff can happen. And for the last part, just for the most part, we're actually pretty fortunate that I think we're getting an opportunity. So when I did the 2011 Pen Testing Considered Harmful talk, one of the things that I said is that I thought we were heading for almost a financial meltdown kind of situation, because people were paying us lots of money and we weren't addressing the problem. And when your organization gets taken, you start looking at your shoes and try to explain why you weren't able to do it. And at the time I said we were heading for this problem where there'd be a complete loss of confidence. And what I'm saying now is we haven't hit that absolute complete lack of break in confidence yet. So we've got an opportunity to kind of try to fix this before we have that moment. And there's lots of opportunities. There's opportunities to do cool things. There's opportunities to build products and make a lot of money along the way, because nobody's solved some of these hard problems. And for the most part, what it needs is for you guys to show up. So you can do a whole bunch to actually make a difference. I'm not sure if we've got time for questions. I'm not sure. So if we do, we'll take some questions. If we don't, at Haroon Meer on Twitter, you can tell me why I'm an idiot and why this is wrong-minded. But again, thank you very much for your time.